Hi, my name is Milos and welcome to Element 14 Presents. It's the holiday season now, and for me that means putting up the Christmas tree, decorating, and of course everyone's favorite part, the presents. There's a lot of joy in giving presents and seeing smiles on other people's faces, but let's be honest, everybody also loves receiving presents. So is there maybe a way that we can go around during the night, take a sneak peek at what's under the Christmas tree? Maybe we can do that with robotics. Let's get started. I will now go ahead and draw my idea for you so you'll get my concept for this project. Here we have a Christmas tree with all of the ornaments, some presents underneath of course. And here on the bottom left you can see our robotic Christmas ornament. So I want to have a live feed from my computer and have some controls. And I want that feed to be transferred over Wi-Fi. So the things we need are the wheels for moving, the small camera, and we need to somehow go up and down the tree. And also some lights for night driving. So we need to have a battery, Wi-Fi, we need to have an internal mechanism for lowering down the wheels so that the ornament can actually transform. Now that you've seen the general idea from the drawing, let's go and develop the project further. First of all, most Christmas ornaments, they come in different shapes and sizes. They can be round, they can be square, a star, tree shape. They can be all shapes and sizes, but I wanted to stick with a round shape like this. For actually this to work, to transform as I've shown you in the drawing, we need to have some kind of mechanism that could actually lower the wheels and the wheels can come out so it can drive around. For that I found a pretty cool software that I'm gonna show you now. I want to show you a free cool website I found. It's called MotionGen. It allows you to prototype different kind of linkages and mechanisms and animate them so you can see how they will work. MotionGen was a really useful site to test out and prototype the linkage system, but let's draw a rough sketch of what I want to make in the end. So of course we want to hang the ornament on the Christmas tree branch. I'm going to use the Arduino Vision as my main computer for this ornament. We will have two drive motors so we can have tank steering with wheels on them of course, and we will have a central motor for actually lowering those wheels. At the top we'll have the winch motor for lowering up and down the whole ornament. 9-volt battery electronics. Here is how the whole mechanism works. The trapdoors open and the wheels drop down when the position servo actuates, and that's how the whole system will work. Let's jump into CAD to actually model this thing and then go to making it. So we have this blue position servo, which by turning 180 degrees will lift these two segments up. These green motors are the continuous rotation servomotors, and this here is just a hole for the bearing that will go here. So how this mechanism works is, if we drive this joint upwards, you can see both sets of wheels going up, and this is how this looks packed. It took a bit of playing to see how big the wheels can be, as well as the distance between the wheels, so everything gets packed nicely. Now let's take a look at how the whole robot will go up. So this is the winch servo, and this is the small winch onto which we will actually just add some thin but really strong fishing line. On top of that goes what I call the upper bridge. This is the platform that will hold all of the electronics, but also has a 4mm hole here for guiding the line from the winch servo to the top of the Christmas ornament. The idea for the 4mm hole is to use a piece of PTFE tubing that's usually used for things like 3D printers, so the line has a smooth path. And on top of that we have the top dome, so this is where the PTFE tube comes out and the line goes out. The last part from the mechanical aspect of the design is the bottom half of the Christmas ornament. The first part is this part, which I call the shell ring. It attaches to the top half. It houses the 6 LEDs that we want for night driving, let's call it that. And it also has the mounting points for the trapdoors. So how this works is I had to put the hinges on the outside for the trapdoors, so the angle at which they can open is enough. They will open at about 150 or 160 degrees, something like that, so that when they're open, the wheels have enough clearance to actually touch the ground without the trapdoors themselves scraping the ground. The trapdoors are actuated using string that's pulled by the same servo that lowers the ground. The string is attached to these holes on the trapdoors. It goes through here and then it just attaches to the same spot as the linkages for lowering the wheels. The only other thing is how do we return the trapdoors. They're returned by attaching to this hole here and here by using a simple rubber band. It's a simple solution, pretty crude, but it does the job. I've connected the Nikla Vision board to my computer so we can test it out a bit. It's an amazing little powerful board. It has onboard Wi-Fi, and as you can see from the bottom right of your screen, it also has a small camera, which will be really useful for this project. My idea is to live stream actually that footage over the internet, and on the screen you can see the OpenMV IDE open, and they even have an example for just doing that for an RTSP video server. So let's go and give it a try. First of all, let's run the script. The first thing it needs to do is connect to the internet, which it just did. We just need the IP address, that's .2. VLC usually can play RTSP streams, but due to the compression that's implemented in OpenMV, it won't be able to do it properly. So we're going to use FF Player, which is a free open source player that you can download, but you need to launch it from the command prompt. So if we type in the address as you see down below and click enter, you will see a live stream. So you can see that there's a bit of a delay between the audio and the video. That's because the stream has a bit of a delay, but it still works pretty good, especially considering this is a small microcontroller. One more thing I implemented here is that I've added some commands so that it can read commands from MQTT. So if you look at the serial monitor down there, you can see the 1 or you can see the 0. I'm just doing this through Node-RED and the dashboard down there. That's pretty much all of the things I will be using from this board. This board is much more powerful and can do many more things, but all I want to do for now is just stream the video over internet and send it some simple commands so we can turn on or off the lights or control a servomotor. Time to assemble the inner mechanism. First things first, let's attach the two continuous servomotors to these brackets. These are the white plastic rings that come with the motors when you buy them, and I just printed out a little shell-like wheel and superglued this into place. For just a bit more traction, I added some tape on the outside that looks like the rubber wheel. The next thing we should do is attach these wheels here. So the idea is to actually make this wheel be at the same height level as this. The best way to check if you've done this properly is to check if it lays flat on the table. If it does, that's it. There are two types of servomotors. These are the continuous rotation ones that we will be using for actually driving. But for lowering them down, we will use this position servo. But first we need to mount these servos to this bracket. You just want to make sure that both can move freely up and down so that the wheels can actually go up. So what we need to do now is get the servo to either 0 or 180 degrees, it doesn't matter, but we need to get it into one of those positions. To do that, I will be using this Arduino Uno, which already has a sketch on it that will just send the servo to one position and then to the other and do that in a loop. So we just need to catch one of those positions. And if you take a look now, every 3 seconds it will go from one side to the next. Okay, now that that's done, we need to attach these little arms. You want both of these to line up with this hole right here. And as you can see now, this is how our mechanism works. These are the wheels lower down and these are the wheels up. And when we want to drive out, it does this and that's it. So the idea with the string is it will pull the trapdoors from the outside so they open. And with that we have attached the winch motor to the main assembly. Before we actually screw it on, it's much easier to now thread all of the wires through. And now we're supposed to attach this whole assembly to the top dome. And with that we have the whole top half assembled, as you can see. Before we actually assemble all of the electronics, put everything inside and also add the trapdoors, I think it would be fun to actually test out the winch, seeing the whole robot going up and down. I've just hung it using a keyring on my top-down filming rig, and I've attached the Arduino that we used for testing the servomotors. So it will go one way for 3 seconds and the other way for 3 seconds. So let's power it on and see what happens. It's going up now. It's going up a bit slower than going down because of the force that's actually applied to the motor. But again, the motor is plenty powerful to actually get the whole Christmas ornament up, which is amazing. This is by far my favorite part of the mechanism. Now that the top half is complete, all that's left to do is assemble the bottom half. So this is the shell ring we've assembled previously and soldered and tested the LEDs, as you can see here. Now let's first attach the rubber bands before attaching the trapdoors to the shell ring. And as you can see, both are now moving pretty free. We need to tension this rubber band, and with that everything is finished when it comes to the bottom side. So now when we open this, it will just close because of the rubber bands. So that will be it for the whole mechanical assembly of the Christmas ornament.
Do you like winning free stuff? Are you an electronics hobbyist? Do you like building cool projects and winning prizes for what you build? The Element 14 community presents Project 14, the member-driven destination where you decide on the challenge. You enter projects to win monthly prizes and you vote on the winners. What are you waiting for? Join the Element 14 community so you too can enter one of our contests or submit an idea for your own. Join now!
Now that we're done with all of the mechanics around the robot, let's take a look at the electronics and all of the things that will go into the robot. So I want to power the robot using the 9-volt battery, but we need to drop that voltage down to 5 volts to power the NICLAvision. The V-in pin on the NICLAvision can handle anywhere from 4.5 to 5.5 volts. So I will be using a linear regulator to drop the voltage down to 5 volts. Besides that, I'm using a small MOSFET to actually control the 6 LEDs for the lights, so we can also drive the robot at night when nobody's looking at the Christmas tree. And besides that, we only need to control the 4 servomotors. To actually control them, I had to add small transistors because the pins actually weren't strong enough to drive the motors properly, especially the continuous ones, because the PWM signal just didn't look too good, and this is the easiest way I found to fix that. Okay, so let's go and solder this before we can actually assemble the whole robot completely and test it out. We're back in OpenMV and this is the final code I will be using for the robot. So it's pretty simple. All I want to do is stream the video feed from the NICLAvision to my computer and also be able to send some simple commands over Wi-Fi. This whole code is built upon the base of the RTSP streamer that you've seen previously, and I'm just using an MQTT client to receive the commands. To actually control everything that we need to turn on and off the lights. That's just a simple GPIO toggle, and we need to generate PWM for the servomotors. So this is how I generated the PWM using timers, and this is just how I mapped it so I can easily use them. I don't need anything in between, I only need the end positions. Meaning I want it either to go as fast as possible, as slow as possible, or the position servo to go from one endpoint to the other. So these are the values that we actually want to send, and these are the commands that we want. If you want, you can pause the video and check them out, but we just parse them from the MQTT message that we get, and depending on that we just update the PWM for that channel. So we can go forward, back, left, right, put the wheels up or down, turn the lights on or off. And while we're doing all of that, we're also live streaming. So that would be the whole code. And our ornament is finished. This is a great little robot. It was really challenging sticking to a round shape. If I had gone with a square box, it would have been much easier, but I think it was a pretty nice and fun challenge. Not everything works as well as I wanted to, as you will see now in the testing, but nevertheless it was really fun designing and building it. The hardest part was actually getting all of the electronics in. It ended up being 100 millimeters in diameter, but a pretty heavy Christmas ornament. It actually weighs 300 grams. Let's go and test it out on the bench and then put it on the Christmas tree to see if we can maybe spot some of the presents underneath. I have the robot hanging from my camera rig again. Let's first lower down the wheels. There they go. Okay, now we can slowly start winching it down. Okay, we are on the ground. Now we can even drive a bit. And we can of course winch ourselves up if we want to return to the tree. I have some issues with the trap doors. They can't close up properly. So I have to use a piece of tape to close them up because of the strings and the geometry, but the opening up is good enough for testing. Okay, now you'll be able to see the full setup on how I actually control the whole robot. So you can now see me while the camera live streaming. There's a bit of a delay that you will probably notice when you listen to the audio and look at the video, but here you can see my controls. So for example, we can go winch down. There it goes. We can stop. We can go winch up. Let's go winch down and drive around my table a little bit. I let it get a little extra string out so we can maybe drive forward, stop driving, turn to the right. Let's drive towards the mess of cables that you can see. Not bad. Maybe turn right again. A bit more right. Let's go towards the tripod. And we can winch ourselves up now. Okay, so the robot is on the Christmas tree with all of the other ornaments. It's in a dark room, so let's see if we can figure out any of the boxes underneath the tree. Let's start the stream. Here on the right you can see my controls. And if we get the wider screen, it's pretty dark. Let's turn on the lights. Okay, I think that's the door. Let's winch down slowly. Okay, I think we should be down. And turn on the lights again. And let's rotate a bit. Okay, I see some wrapping paper. Let's go a bit more to the left. Oh, what do we have here? A bit to the back. Reverse stop drive. Oh, and that's a Lego set. Everybody loves Lego. This was a really fun project to work on. Kinda challenging sticking to a round shape, modeling around the round shape, and generally just packing all of the electronics. The Nikla Vision board is just amazing with its size and all of the features that it has, so it was really the key component for this Christmas ornament. Not everything works as good as I would like to, like the trapdoor opening, but that's something that can still be upgraded. I'm still really happy with how it turned out. If you want to try out yourself, you can get all of the code, CAD files, and all of the other resources on the link down below on the Element 14 community. If you have any questions or comments, please leave them down below. Happy holidays, and I hope you had fun watching this video. See ya!